Good. My name is Shrikam and I'm studying in Sri Venkateswara College of Engineering. And today my topic is normal distribution and application applied in math. Introduction to normal distribution. The normal distribution, also known as the Gaussian distribution, is a fundamental concept in statistics. It is characterized by all bell-shaped curves which is symmetric about the mean. Many natural phenomena such as height and test scores tend to follow this distribution. Here is the graph of a normal distribution which shows the bell curve in it. Now, properties of normal distribution. One of the key properties of a normal distribution is that it is defined by two parameters, the mean and the standard deviation. The area under the curve represents the total probability which equals 1. Approximately 68% of the data falls within one standard deviation from in a mean normal distribution. Importance of mean and standard deviation. The mean indicates the central location of the data set, while the standard deviation measures the spread of the data. Smaller standard deviation results in steeper curve indicating the data points are closer to the mean. Conversely, a large standard deviation leads to flatter curves showing greatness variability among the data points. Calculating standard deviation is Sx is equal to square root under x minus x bar whole square by n minus 1, where n is the number of data points, xi is each of the value of the data, and x bar is the mean of xi. The standard normal distribution. The standard normal distribution is a special case of normal distribution with mean of 0 and standard deviation of 1. It allows for the comparison of different distributions through the use of z-scores. A z-score represents how many standard deviations a point is from the mean, facilitating standardization. Here in this graph, we can see that mu minus 3 sigma and so on. It shows the standard deviation from 99.972% to 95 to 68.67% as an example. Application in statistics. Normal distribution play a crucial role in inferential statistics, particularly in hypothesis testing. Many statistical tests such as t-test and ANOVA assumes the data follow a distribution. It helps in estimating population parameter and determining confidence intervals for sample means. The empirical rule. The empirical rule or the 68, 95, 99.7 rule describe how data distributed in a normal curve. According to this rule, 68% of data falls within one standard deviation, 95% within two, and 99.7 within three. These rules provide a quick way to understand the distribution of data complex calculation, probability density, and here's example of 60, 95, and 99.7 rule. We can see that 99.73 covers the large area under the curve, so followed by 95.45 and 68.72. Central limit theorem. A central limit theorem that distribution of sample means approaches a normal distribution as a sample size increases. This theorem is crucial because it allows for the application of normal distribution to various data types. It ensures that even if the original data isn't normally distributed, the normal with a large enough sample size. Here we can see the example of 68% where 60% of all the values are within one standard deviation of the mean value. 95% of all are within two standard deviation of mean value, while 99% of all values are within three standard deviation of mean value. Limitation of normal distribution. Not all datasets follow a normal distribution which can be inaccurate. conclusion if assumptions are violated. Skewed data or data with outliers may not fit the well necessity of alternative statistical methods. Understanding the limitation helping statisticians and researchers use appropriate analysis for their data. We can see the number of deviation of the mean curve in the following example of a shape normal distribution, where of each have an equal half in it. Conclusion and future application. Normal distribution remain a vital concept in field, including psychology, economics, natural sciences. Its application in data analysis and statistical methods continues to evolve. Normal distribution and research. As we gather more data, understanding normal distribution will remain essential for interpreting and making decisions based on statistical information.